Nearly 4,700 years ago in the sun-baked sands of Egypt, Pharaoh Djoser and his visionary architect Imhotep dared to build the world's first pyramid. This was no ordinary tomb. It was a groundbreaking architectural feat that would set the stage for all future pyramids. They ingeniously stacked mastabas, which were traditional flat-roofed tombs, creating a monumental staircase to the stars. The Step Pyramid at Saqqara. This was a radical departure from the usual burial practices of the time. This awe-inspiring structure still stands today, a testament to ancient Egyptian ambition and engineering prowess. It continues to draw visitors from around the world, all marveling at its enduring grandeur. But how did they achieve this monumental task? How did ancient Egyptians, armed with only copper and stone tools, manage to move and place such massive stones with such incredible precision? The tools they had seemed rudimentary by today's standards, yet their accomplishments were anything but. The conventional story is one of sheer manpower, thousands of laborers dragging enormous stone blocks up ramps under the relentless Egyptian sun. This image of tireless workers toiling day and night has been etched into our collective imagination, yet this explanation feels incomplete. Could there have been a smarter, more efficient method? Modern archaeologists and engineers have long debated this question, searching for clues that might reveal a more sophisticated approach. The ancient Egyptians were masters of the Nile, harnessing its waters for life and agriculture. Their deep understanding of hydraulics and irrigation was unparalleled in the ancient world. Might they have used their extensive knowledge of water to aid in the construction of their greatest monuments? Some theories suggest that water could have played a crucial role in transporting the massive stones. Could the Nile itself hold the secret to the pyramid's construction? As we continue to explore and study, the enduring puzzle of Djoser's Step Pyramid may one day be fully unraveled, revealing the true genius of ancient Egyptian engineering. Let's embark on a journey into a bold new theory, one that reimagines the ancient Egyptians not just as master builders, but as pioneering hydraulic engineers. What if, instead of relying solely on brute strength and ramps, they harnessed the power of water to lift and move the massive stones that built the pyramids? Picture the construction site, not as a barren, dusty plain, but as a vibrant network of canals, dams, and water-filled locks. Imagine the landscape transformed, with shimmering waterways weaving through the heart of the project, connecting the Nile to the very base of the pyramids. The core principle behind this theory is elegantly simple: buoyancy. When submerged, even the heaviest stones become lighter, almost as if the water itself is lending a helping hand. This natural force could have made the impossible possible. Living alongside the mighty Nile, the Egyptians would have observed this phenomenon daily. Their lives revolved around the river, and their deep understanding of its cycles and properties would have made them uniquely equipped to exploit its power. According to this theory, they ingeniously diverted Nile water to the pyramid's base, creating artificial channels and pools. Here, they could float massive stones directly into position, reducing the need for backbreaking labor and complex ramp systems. Instead of dragging enormous blocks up steep ramps, workers could have floated them upward step by step, using a series of water locks or lifts. Each stage of the pyramid's construction would be carefully coordinated, with water levels raised and lowered, to move stones precisely where they were needed. This vision transforms our understanding of the pyramid builders. No longer just laborers toiling under the sun, they emerge as ingenious engineers, innovators who mastered both stone and water to achieve their monumental goals. To make this system work, they would have needed to master the science of fluid dynamics and water management. Designing and maintaining such a complex infrastructure would require careful planning, precise calculations, and a deep knowledge of the river's behavior. The infrastructure would likely include a dam to control water flow, purification basins to ensure clean water, and a series of hydraulic lifts or locks to raise and lower the stones as needed. Each component would play a crucial role in the overall process. In this way, every part of the system formed a liquid assembly line, seamlessly transporting stones from the distant quarries, along the Nile, and finally to the construction site, ready to be set in place. Now let's break down how this remarkable water-powered construction process might have unfolded, step by step, revealing the ingenuity and resourcefulness of ancient Egypt's master engineers. The process would begin with a massive dam, an engineering feat in itself. The Nile's annual flood was unpredictable, so the Egyptians needed a steady, controlled water supply. They may have built a huge reservoir near Saqqara, capturing floodwaters and creating a harbor for stone-laden boats. This dam would have turned the desert plateau into a waterfront construction zone. Selecting the right site and building strong retaining walls would require deep knowledge of geology and hydrology. The dam would regulate water flow, acting as a giant valve for the builders. Evidence of ancient Egyptian dams, like the Sa'd el-Kafara, shows they had the ambition and skill for such projects. Discovering a dam at Saqqara would be the ultimate proof of this theory. It would rewrite our understanding of ancient engineering. Nile water is rich in silt, great for farming but disastrous for hydraulic machinery. The next step, a purification basin where sediment could settle out before water entered the lifts. This wide, shallow pool would use gravity to clarify the water. Clever design with baffles and sluice gates would maximize sediment removal and allow for easy cleaning. Managing such a basin required careful planning and maintenance. This wasn't just a pool, it was an industrial-scale water filter. The Egyptians' attention to detail ensured their hydraulic system ran smoothly. They understood not just stone, but the properties of water itself. The purification basin was a crucial link in their construction chain. With clean water ready, the real magic began, lifting the stones. The hydraulic lift, inspired by canal locks, was a water elevator built alongside the pyramid. A stone block, attached to a flotation device, entered a sealed channel at the base. Water from the reservoir filled the channel, raising the block effortlessly as the water level rose. Once at the right height, the upper gate opened, and the block floated onto the pyramid's next level. Workers could then guide it precisely into place. The process was efficient, repeatable, and required far less brute force than ramps. Draining the channel reset the system for the next block. As the pyramid grew, the lift's walls extended upward, scaling with the monument. This scalable solution could have revolutionized construction. It's a brilliant application of ancient physics. But how do you make a heavy stone float? The answer: flotation devices. Egyptians could have used sealed wooden rafts or inflated animal skins to cradle each block. The key was matching the float size to the stone's weight, a practical application of physics and math. In a staging area, each block was secured to its float and guided into the lift. Once raised, workers used ropes and levers to maneuver the buoyant block across a shallow, water-covered surface. Floating the block allowed for fine, gentle adjustments, explaining the pyramid's astonishing precision. Water reduced friction, making placement easy and accurate. This method valued ingenuity over brute strength. The water acted as lift, lubricant, and positioning tool all at once. It's an elegant solution for both scale and quality. The hydraulic system could explain the pyramid's enduring perfection. For centuries, the most widely accepted theory of pyramid construction has centered on the use of massive ramps, ropes, and the sheer determination of thousands of workers. These traditional ramp theories paint a vivid picture: endless lines of laborers, straining together to haul enormous stone blocks up steep, winding inclines that snaked their way alongside the rising pyramid. The scale of this operation is almost unimaginable, with the ramps themselves stretching for hundreds of meters and requiring constant maintenance and expansion as the pyramid grew taller. But when you look closer, these ramps would have been truly colossal, sometimes nearly as large and complex as the pyramid itself. Building and dismantling such structures would have demanded enormous resources, time, and coordination, raising questions about their practicality. The logistics and labor required for this approach seem almost impossible to fathom. Imagine the food, shelter, and organization needed to support such a massive workforce, not to mention the risk of accidents and delays. The hydraulic theory doesn't dismiss the importance of ramps and manpower entirely. It simply reframes their role in the construction process. Instead of being the main method, ramps and human strength become supporting players in a much more sophisticated system. Small ramps and the muscle power of skilled workers were likely used for moving stones over short distances, making fine adjustments, and positioning blocks precisely where they were needed. Ropes and levers, simple yet effective tools, remained essential for guiding, lifting, and shifting heavy blocks, especially in tight spaces or for delicate maneuvers. But the most challenging task, lifting multi-ton stones vertically to great heights, was likely achieved with the ingenious use of water power. harnessing the natural properties of buoyancy and hydraulics. This innovative approach allowed a smaller, highly skilled workforce to operate more efficiently, reducing the need for massive armies of laborers and speeding up the entire construction process. Once the hydraulic infrastructure was in place, the building of the pyramid could proceed almost like an ancient assembly line, with stones moving smoothly and predictably from the riverbank to their final resting place. Water-powered lifting wasn't just a possibility. It was an elegant, sustainable solution that minimized waste and maximized efficiency, perfectly suited to the Egyptians' environment and resources. This method fits seamlessly with the Egyptians' deep understanding and mastery of their river environment, turning the Nile's life-giving waters into a powerful construction tool. The water theory offers a smarter, more harmonious vision of pyramid building, one that blends human ingenuity, teamwork, and the natural world. Ultimately, it's a testament not just to human endurance, but to the creativity and resourcefulness that defined ancient Egyptian civilization. If the hydraulic theory is true, it transforms our view of ancient Egypt. Their achievements become not just feats of labor, but of scientific brilliance. The Egyptians were not just builders, they were engineers, physicists, and innovators. Their knowledge of astronomy, mathematics, and medicine is well documented. Why not see their engineering as equally advanced? The Step Pyramid may have been one of history's first great scientific experiments. Imhotep emerges as a pioneering hydraulic engineer, not just an architect. The pyramids stand as monuments to human intellect and creativity. The hydraulic theory raises new questions and challenges us to seek evidence. Where are the remains of dams, basins, and water channels at Saqqara? Archaeologists can use modern technology to search for these hidden structures. Core samples might reveal ancient silt layers hinting at lost lakes. Experimental archaeology could help reconstruct and test these ancient devices. The quest to understand pyramid building connects us to our ancestors' curiosity and drive. Whether proven or not, the theory inspires us to rethink the past. The answers may still lie buried, waiting for discovery.